Hi everyone, my name is Christian Aguilera Sandoval. I'm your Southeast Application Scientist. In today's module of FlowJo University, we're going to be talking about data scaling and the T button in FlowJo version 10. The T button, or the transform button, is used mainly for two reasons. One, resolving densely packed data on either the X or the Y axis, and two, to modify scaling to optimize your data visualization. Importantly, the transform button can be used on all parameters, including your ratiometric and/or derived parameters. In this figure, as you can see, when we have data that has been brought in from your FCS file prior to transformation, you have events that are quote-unquote squished or densely packed against the edges. After we apply the transformation, then you can see that these populations get resolved and we're able to truly view all the events associated with these parameters on both the X and the Y axis. And what do I mean with data scaling? Well, we have different scales. Linear, which is mostly used for your FSC and your SSC parameter, which are used generally for size and for complexity respectively. We also have logarithmic, which covers a wide dynamic range, and these are mostly used with all your fluorophore channels. However, what is ideally used in fluorophore channels and commonly used is the bi-exponential scale. Bi-exponential scale is a hybrid of both linear and log. It has three settings to be optimized within FlowJo that we have are adding positive and adding or subtracting positive or negative decades, as well as playing with the width basis. Our bi-exponential scale is based on Dave Park's transformation process, which was previously published in 2000. Now that we've talked about the ideas and the purposes of the T-button and data scaling, why don't we do some live analysis to see what this actually means in action. So in this example, we're looking at CD4 and CD8 T cells. And as you can see, like I previously showed you in another figure, we have events that are against the edges right here and on the x-axis. You may also normally, if you have a lot more than 8% of those events, you'll get this warning at the top that says, warning, X% in this case being 11% of events are on the chart edges. So how do we solve this? How do we view all of our events like I previously discussed? Well, these are the mechanics. Let's first fix our T button for the y-axis. We left click once on the T button, and then we say customize axis. Here, I'm going to move this to the side so we could view in real time what is happening. Like I mentioned, we have three modes to be able to optimize our visualization of bi-exponential scale: the adding or removing extra negative decades or positive decades, and then also the width basis. Now, you may be wondering, what does adjusting width basis do? Well, adjusting the width basis compresses a number of channels into the linear space around 0. And you may be wondering also, well, but why do I have events that are 0 fluorescence or with negative fluorescence? Well, there's nothing wrong with your data. It's more that it's mostly due to two reasons: either a baseline correction by the instrument, or two, a photon counting error, which has introduced a spread of measure intensity values due to inaccuracies in the PMT. But that's not a big problem. Let's just go ahead and fix this, right? So we could analyze our data. So like I mentioned, let's go back over here. And the way I would recommend to optimize this is start with your width basis. If that doesn't resolve the issue, then we could start playing with the extra positive or negative decades. Well, here we're going to go ahead and play with the width basis. There we go. That way we don't have any events that are squished or compressed on the axis, right? As you can see here. Also on the other side of the axis, we have nothing's compressed. We're going to click on apply and Please now view that the y-axis has now changed, where we're getting complete resolution of the CD4 positive T cell population as well as the double negatives. And you can see here, we even have a little bit of empty space. Also, you would notice that your gate gets automatically changed to fit the scale that you have now done. Now let's correct our x-axis. Let's again click on the T transform button, and then we're going to click on customize axis and move this to the side so we can see what's happening. Let's again play with the width basis. Well, there we go. Then we click on apply, and there you go. Now we have all of our events. As you can see, our prior gates were not completely taking into account all the events associated with the CD8 and the CD4 T cells. This is why it's extremely crucial and critical that you do not gate on events without having done the transformation, because you may be missing on some of your important events. So now we could just go ahead and modify our gates to go ahead and include all of our CD4 and CD8 events. A question that may rise in your mind is, well, am I changing the data? The answer is no. You're not at all modifying the data that was acquired. You are only changing its visualization and the amount of visual space. So you do not need to be concerned. Other buttons that showed up when you click the transformation button, and let me discuss those briefly, is the scale. And this is what I previously discussed. We have the linear, the logarithmic, and the biax. We have other that are more that are instrument specific, like the Miltenyi scale. Okay. All right. What about if you have an instrument that you routinely always have to transform? This could get tedious. Well, at FlowJo, we've taken care of that. So what you can do is click on the heart for preferences. Then you go to cytometers. And what you're going to get on this side of the panel is all the type of data that you have, that your FlowJo has previously seen. Okay. Here, you could either use the default scaling, or you could then go ahead and modify it according to your own cytometer's scale. You could also enable transforms with the width basis here, where you're able to control what you're seeing. And you could change the cytometers here. That way you're not always visualizing what, let's say you have 2 or 3 different cytometers in your core, then you would adjust it to whatever it is that your cytometer is you're using for that data acquisition, and saves you some time for the transformation. I hope this was helpful. Please feel free to reach out to us at tech support or myself if you have any questions or if you need any help. We are more than happy to provide that. Thank you again, and I hope you have a great day.